which is the true relationship for hexa-aqua-ion 2 complex. So here we have two terms in the option. One is delta O, the other one is P. Delta O is crystal field splitting energy or crystal field stabilization energy for octahedral complexes, and P stands for pairing energy. So this entirely depends, the relationship between them entirely depends on the nature or the type of ligand. Here in this particular case, it's water. So we'll consider the complex, that's FeH2O 6 times 2 plus. Iron is in plus 2 oxidation state, so the configuration would be 3d6 4 is 0. So there are 6 electrons here. And now when all the ligands are coming from equidistant, this is Fe2 plus. And when all the ligands are coming from the same distance, the energy increases due to the repulsion of the ligand electrons and the metal electrons. Now, since it is an octahedral field, this is going to split into 3 and 2. That's dxy, dyz and dzx. This forms T2g, and above orbital, which is higher in energy, is called as Eg. Now, this energy difference between them is called as CFSE. And the energy required to pair up the electrons here is called as pairing energy, which is denoted by the letter P. Now, when you have one electron field here, so the one electron goes here, the second electron goes here, third electron goes here. For the fourth electron, you have two options. One is it is going to fill here or it is going to jump here. So you have two options. These two options depend on the difference between CFSE, that's delta O, this is also called as delta O, and pairing energy. If this is more and this is less, then electrons will choose this path. That depends on the ligands. Then crystal field stabilization energy is less, so the electrons are going to jump here. And you get in this type of ligands, it is the type of ligand which is weaker. And the other option is delta O, that will be greater than the pairing energy. So electrons are going to pair up. This is in case of the strong ligands. So here the ligand, which is water, which is relatively weak. So you can expect sp3d to hybridization, and the electrons here, instead of pairing up, they go to the higher level. As a result, the option is delta O, that's lesser than P. The answer is option A.